Hi guys, in this video we'll answer the question 19 of the 2020 external non-calculator short response exam. A horizontal point of inflection is a point of inflection that is also a stationary point. Determine the values of k for which the graph of f of x equals ln x over k minus kx over x plus 1 has only one horizontal point of inflection. So if a was our, say, x value at horizontal point of inflection, we know that at this value, f dash a will equal 0 because it's a stationary point. And because it's also an inflection point, we know that the second derivative at a will also equal 0. So if we get these two equations, we'll have two equations and two unknowns, which is k and x, and we can solve it using simultaneous equations. So let's first find f dash of x. So for that, we'll have to derive our f of x. That's going to be ln x derives to 1 over x, and we've got a constant before it, which is 1 over k. This, we can use quotient rule to derive that because we've got x in the numerator and denominator, and it's a fraction. So if we differentiate that on the side here, let y be kx over x plus 1. So our u is going to be kx, and our v is x plus 1, and our u dash is k, and our v dash will be just 1. And the quotient rule tells us that the derivative is u dash v minus u v dash all over v squared, and that's when y is u over v. So that's our u, and that's our v. Alright, so the derivative is going to be u dash, which is k, times v, which is x plus 1, minus uv dash, so u is kx, times v dash, which is just 1, so that's that, over v squared, x plus 1 squared. Let's simplify this. So this will become kx plus k minus kx all over x plus 1 squared. And we know that kx minus kx will just cancel, and it will end up equaling k over x plus 1 squared. So here we can now write that back in, 1 squared. So this is f dash of x, and we know that when x is a stationary point, then this will equal 0. So we can say that. Now, this is our first equation. Now let's also find f, the second derivative of x, which will be deriving this. So d over this was supposed to be over dx of, so I'm going to write this as x to the negative 1 over k, just because it's easier to derive. So anytime you bring a denominator to the numerator, the power becomes a negative. And same thing here, minus k, and I'm going to bring this to the numerator as well, and it's going to become to the negative 2. So let's differentiate that. So this will become negative x to the negative 2 over k minus k times negative 2, so it'll be 2k x plus 1 raised to negative 3, making it all positive powers, so turning that negative 2 into positive 2. We can do that by bringing the whole thing to the denominator, so it's going to become kx squared plus 2k over x plus 1 raised to 3. Again, the negative 3 becomes a positive 3 because you've moved the whole thing to the denominator. Now again, when it's a point of inflection, this will equal 0. So now this is our second equation. So if we solve equation 1 and 2, they're simultaneous equations, it will give us the value for k and x. All right, so let's rearrange 1 so that we can sub it into 2. So 1 on kx, so I'm rearranging this equation here, equals k over x plus 1 squared. Multiplying both sides by kx, we're going to have 1 equals k squared x. And also multiplying both sides by x plus 1 squared will give us so we've just cross multiplied. And now if I divide both sides by x, then k squared is going to be x plus 1 squared over x. All right, I'm just going to leave it like this for now. And now let's rearrange this into a form where we can have k squared. So it's just easy to sub this in. So if I bring this to the other side by adding it on both sides, I'm going to have this. So I'm going to cross multiply again. So we're going to have x plus 1 cubed equals 2k squared, x squared, and then divide by 2x squared on both sides. So we're going to have x plus 1 cubed over 2x squared equals k squared. So let's call this equation 4. And now we know that k squared is actually this. Let's sub equation 3 into 4. And we're going to have x plus 1 cubed over 2x squared equals k squared, which is the same as that. So it's x plus 1 squared over x. Now, again, I'm going to cross multiply. So we're going to have x plus 1 cubed equals 2x squared, x plus 1 squared. Now, if I divide by x on both sides, we're going to have x plus 1 cubed equals 2x, x plus 1 squared. If I divide by x plus 1 squared on both sides, we're just going to have x plus 1 equals 2x. Let's minus x from, so now we don't really need the brackets because there's nothing happening to it. And now let's minus x on both sides. So we're going to have 1 equals x. So our a value is 1 when we have a horizontal point of inflection. It's a point of inflection and it's also a stationary point. All right, now let's look at the question again. So the question's asking us for what values of k does it have only one horizontal point of inflection. So the point of inflection is at x equals 1. So, but we need to find what value of k does that. Well, we know that this equation can give us the value of k. So let's sub x equals 1 into equation 4. So we're going to have 1 plus 1 cubed over 2 times 1 squared will give us k squared. So this is 2 cubed, which is 8, over 2 times 1 squared, which is just 2. That's going to be 4. And so k is going to be the square root of 4, which is plus minus 2. So determine the values of k. So the answer is going to be when k equals plus minus 2 is when we have only one horizontal point of inflection, which is at x equals 1.